Hello, wherever you are, I hope you're doing well and you're ready to do the chemistry question. Today's question is about percentage yield. So related topics you might want to take a look at are organic reagent conditions. Lots of marks, as I've said before, to be picked up if you know your reagent conditions. Organic reactions and balanced equations, naming and drawing organic molecules, and percentage yield calculations. These are all related to the mole concept, amounts of substance, and as it's a calculation, pay close attention to how you set your working out. Here's the question. Pause the video, read it, have a go, and press play when you're ready for the answer. Welcome back. This is the format that I like to use. Black text is the question, blue the model answer, and red text for any additional information. Before we can attempt this question, we need the balanced equation, so you really need to know your reagents and conditions. This helps us to establish that 1 mole of the haloalkane will make 1 mole of the alcohol in theory. I've abridged the question there to get straight to the point. Just a word when you're setting out your working out, be very clear. This is 3 marks, and so you can get a lot of marks from methods where you're heading towards the right answer. However, that's only going to be applicable if it's clear to an examiner what it is you are trying to calculate. The amount of the haloalkane we can derive from mass over molar mass. The amount of the alcohol is the same as the amount of the haloalkane theoretically because it is a 1-to-1 reaction. The actual amount of the alcohol, again, we can get from mass divided by molar mass, and the percentage yield is given by the equation actual divided by theoretical times 100. You don't get any of those equations in the exam, they're not on the data sheet, you simply have to know them. We've established that it's a 1-to-1 reaction, and so on the next slide we've just got rid of that balanced equation now. So how are we going to get our masses and our molar masses? The mass of the haloalkane, well, we're given a volume and we're also given a density of the haloalkane as well. So we can get to the mass by the volume multiplied by the density. So that's that 2.0 multiplied by 1.26. The molar mass was given to us in the question. That works out at 0.018408. Now I've included 5 significant figures there. I don't want to get any rounding errors in process, so a couple of extra decimal places I'm using for my in-process results. Theoretically, as it's a 1-to-1 reaction, you'd expect to get the same amount of the alcohol. The actual amount of the alcohol is given to us by mass over molar mass. Now there's a conversion. In the question it gave us 895 milligrams. You have to know that 895 milligrams is equivalent to 0.895 grams, and again you just have to know that conversion. It's not given to you in a data sheet. That works out at 0.012095. So we've now got the actual amount of the alcohol, we've got the theoretical amount of the alcohol. We simply need to substitute those into the percentage yield calculation. The numbers are given there, and that works out quite neatly to 65.7%. I've given my answers of 3 significant figures because that's the number of significant figures in the question for the majority of the variables. Because the 2.0 centimeters cubed of the haloalkane is only 2 significant figures, I believe 66% would also be acceptable. Thanks for watching. New videos are added regularly. Subscribe if you don't want to miss out. Questions about this video and requests for future content are very welcome. You can use the email address on the bottom of the screen, or post in the comments. Take care.